Hello, my name is Larry, and today we're going to be doing a brief introduction of the external components of the GRM 3000T high-performance production tamping machine. Now we're going to discuss some of the outside components on the GRM 3000. Back here we have the rear buggy. Located on the rear buggy is a slope sensor used for cross-level correction. Down below that, there's also a lining cylinder used for lining tension, tightening the lining cable. Down here we have a AGGS encoders used for measuring distance. A feeler rod which is connected to the lifting cables. The feeler rod goes clear to the top of the machine and the lifting cable attaches to it via a roller. The next thing we have is the rear axle. The rear axle has a 2-speed gearbox. Next, from the left side of the machine, we're going to be talking about the tamping units. The tamping units, there's four different independent tamping units. They can be controlled independently by the operator and used to control the depth of these tamping units. We have a depth transducer. The depth transducer is controlled by the operator on the touch panel, and he controls how deep the tamping tools go in the ballast for different size rails. Moving on up, we have a lining buggy. The lining buggy consists of a lining versine. The lining versine is used for measuring alignment. A slope sensor. The slope sensor is used for AGGS measure mode for measuring super elevations and curves. A feeler rod. The feeler rod goes up to the top and attaches to the lift sending unit. The lift cable also goes through that sending unit. Here we have the hydraulic accumulator. This is our automatic lubrication system for our tamping units. This system completely lubricates the tamping units on a timed interval. Moving forward from the tamping units, we have the rail clamp assembly. The rail clamp assembly has a lifting cylinder on each side. This cylinder is responsible for lifting the rail to the desired height. The lining cylinder is used for lining the track horizontally, left and right. We have a rail clamp roller on the front. We have 2 rail clamp rollers on the rear, one on the outside, one on the inside. Additionally, we have a rail hook. The rail hook is used in conjunction with the rollers or used without the rollers if the rollers cannot be used. In the middle we have a lining roller. The lining roller, you can see, is viewed between the roller clamps. On the other side of the machine, on the lining roller, we have the roller just like that is a sliding axle, which we call gauge comp. That gauge comp allows the rails not to spread when you clamp the rail with the hooks. It holds the rail still. There's another depth transducer for the hooks. The depth transducer for the hooks allows the operator to set the depth of the hooks. The hooks can go down and hook under the base of the rail or the ball of the rail, totally controlled by the PLC touch panel. Moving forward from the clamp frame assembly on the left side of the machine, we have the blue hydraulic tank. On the other side we have the green diesel fuel tank. On the upper left corner we have an emergency pump. This pump is used to pick up the rail clamp assembly or the tamping units in case we lose hydraulic pressure. Inside here we have a pump drive gearbox. This pump drive gearbox is connected to the diesel engine. On this model we are using a Cummins engine, and we have 4 hydraulic pumps. The hydraulic pumps are used for travel, work pressure, and vibrators, and for the oil cooling system. Moving forward from that, we have the diesel engine. And last but not least, we have the engine oil drain and a gearbox oil drain. This is the battery box on the GRM 3000. Opening the battery box, we have 2 8D 12-volt batteries. These 2 batteries are hooked in series to supply a 24-volt system to our Plasser tamper. Next to the battery box, we have the battery key switch or master switch. This is used to connect battery power to the machine. Moving forward from the engine compartment, We have the front axle. We have the oil cooler. We have our Atlas tie finder. The Atlas tie finder sensor is used for detecting the tie locations where they're placed in the track, fed back to the Atlas computer for fully automatic tamping of the ties without any operator intervention. We have the short boom located here. Here is the long boom that we currently have hooked up to the front buggy. Moving forward, we have the front buggy of the machine. The front buggy, as you can see, has 6 rolling wheels, and it has an obstruction limit switch used for our Atlas system. Moving forward, we have a slope sensor. In the next video, I will explain about the cabin components and control panels.